What's up? And this is Sikash Education. And today we have a rather interesting problem. Right? Let me get it up on board. A squared, yep. So it's from one of my homework problems, but let me write it up here. The problem goes like this. It's a differential equation question. So it's y double dash plus a squared on y cubed is equal to 0. Beautiful. That is a question that we're going to be trying to solve today. So best of luck to us. By the way, look at the time. I don't know if you can see it, but yeah, the time is 1:50 a.m. So it's early morning. I guess it's the early morning grind. Nah, I'm kidding. I didn't sleep. I can't wake up. Okay, so let's get on with this question. It's a differential question and it's rather weird. It's not like our normal one. It doesn't look first order differential in any way, shape, or form. But our task, as usual, is to bring it into the first order differential form. But let's keep that aside and let's actually just start working, chunking this way through. This is y double dash. Already? Okay, makes sense. Fair enough. Let's move this term to the other side. So if we start writing from this side of the board, so we have more space. Y double dash negative. Right? It's a plus here, so you take it over the equals to sign, it just becomes a negative. So then we can make a substitution. We can be like, let v. Now why do we make this v? Why are we saying v? Because you know in integration, right? We say u sub. That's just standard notation. That's just standard, what do you call the tango, the lingo. That's just the lingo. Okay. So here, when we're talking about differential equations, it's v. So we're calling the variable v in differential. It's just standard form, or it's just stuff that's been practiced for a long time. It doesn't really matter. You can say s, you can say v, whatever. But we're gonna say v to go along with the lingo. So let v equals what? Let's think for a while. What do we want to let v equals? We can let it equals y double dash. That'll make our life easy. Yeah. So then we can go v and then change everything in terms of v and solve it. But then that's not really solving anything. If we just let v equals y double dash, that's the same as not introducing v at all, because yeah. So what we're going to do is we're going to let v equals y dash. So the first derivative. Now what you notice is that when you differentiate v, so v dash, that's equal to y double dash. And that's pretty cool. Yeah, that's pretty cool. And this dv, well, let's call it dv on dx. Okay? Let's say that's what we want. So then you can put this y dash or this dv on dx here. dv on dx is equal to minus a squared on y cubed. Nice. So with this, we can also call it v dash if we want. Doesn't really matter. Now, what do you think we should do right after this step? Think about it. And I just want to see if you guys can see properly. Is this visible to you guys? Okay. Yeah. Yeah, it's visible. Okay. That should be visible enough. Now let's continue solving this. Now this dv on dx, right? We can use chain rule, so to split it up into what? Well, we want dv on dx. So let's go dv on into something, preferably dx. That's the form we want. And there's a y there, so let's just put dy. So then the dy is just going to cancel out, and it's going to be dv on dx, which is what we want. That is equal to... Now, because of this chain rule, we have not changed anything, because this still remains dv on dx, because these two y's can cancel out, right? And then it's just dv on dx. But this is easier because we do know what dy on dx is. This is dy. Yeah. This is not dv on dx. This is dv on dy. So let me get it. I made an initial mistake. If you spotted it, good on you. If you didn't, sorry for misleading you. That's dv on dy. That one. So we can just sub v dash. So here we can write dy on dx, v dash equals minus a squared over y cubed. Okay, this is turning out pretty nice. It's going in our favor. We can see what we can do next. And this is like really good. It's a really good starting position. Now, what do we do? Can we change it even more? Plus, initially, can you guys even see what I'm doing in the first place? Yeah, can you guys see? Or can you not? Okay. Now, what we're gonna do is, if you didn't notice that, even after I gave you that 30 seconds, you're actually stupid. Because, what am I even saying here? See how we select v equals y dash? So then v dash is equal to y double dash. Okay, that's standard, that's known. But then what's happening here? When v is this is y dash. What's y dash? Y dash is just dy on dx. So here, when we're replacing it, right, chain rule, we get dv by du. dv by dy into dy by dx. That's what we know, and that's v. And that is equal to this. Now what we're going to do is we want to integrate both sides. So let's integrate both sides. And you realized, oh, what are we integrating with respect to here? And then it's just dv and dy here. Well, that's a bad idea. We don't put the integral symbol just yet. Let's move our terms and then put the integral symbol. Okay. Now, what we're going to do is we're going to move this y over to that side. Right? How are we going to do that? We're going to multiply by dy on both sides. So times dy, multiplying by dy on both sides, we get dvv because when you multiply dy, cancels out. Nice. Now we have a dy here and a v here, and we can integrate. So you can integrate v, dv is equal to minus a squared on y cubed, or you can even like, that's just making it look complicated. Let's just integrate minus a squared y to the minus 3 dy. Nice. Nice. And then now, when you go ahead and integrate this, what you notice is that v can become v squared on 2, right? And then this minus a squared, well, let's see. It's minus a squared, that's a constant. You can just take it outside, right? That might as well be outside. Like, nobody's asking for you to be here. Minus a squared. Integral this. Then what happens when you integrate y to the minus 3? Remember integration? It's x to the n plus 1 over n plus 1. Yeah, so it's minus 3 plus 1. And remember, minus 3 plus 1 goes the opposite way. So minus 3 plus 1 is just minus 2. So you're just going to be minus a squared into y minus 2 on minus 2. Nice. So I guess the minus signs cancel out. The minus signs can cancel out. And then v squared on 2 is equal to a squared on y squared. Nice. Now, what happens after this step? Well, I guess we can move the 2 there. So v squared is equal to, and there's also a plus c. I forgot about that. So we can move the 2 over here. So it's 2a squared on y squared plus 2c. And then it's a v squared, right? So we can like square root it with a plus minus. And that's equal to b. I went through that step by step. Hopefully you understood everything I did until this point. If you didn't, let me know down in the comments. Yeah, that's DeepSeek. Yeah, not ChatGPT, just DeepSeek. It's much better. So, what to do now? You're like V, but then the question is not in V. That's just something you introduce. V is just y dash. What's y dash? dy on dx. So you can put it back. Y dash is equal to plus minus 2a squared on y squared plus 2c1. Okay. Now this is y dash. So to get y, you want to integrate this. So you want to, so y is equal to, let this be star, right? You want to integrate this star with respect to dx, of course, and dy. That's how you get your final answer. Now, do you guys have any ideas running in your mind on how you're gonna do this? How are you gonna do it? Well, look, once again, this is pretty simple, and we're gonna have to use a u sub pretty soon. So brace yourself. This, right? Let me write it in the top. I raised that. Hopefully it's alright. So then v is equal to, no v. We just said that v is okay, come on. It's been 10 minutes. Let me try to speed it up. It's 2 a.m. now. I gotta go sleep. So v we just said was y dash. So then y dash, because remember the sub we had here, y dash equals, now let v equals y dash. That was a sub. So then y dash is equal to this one, plus minus square root of 2a squared on plus 2c1. Nice. Now you can write this plus minus. You can write this as dy on dx equals the plus minus of the square root. Right? Now think about it. Think about it. What do you think? Exactly. You guys are actually thinking in the right direction. I'm actually really happy. Exactly. Oh. Can you guys even still see? Okay. I don't know. I checked the answers. They're saying something else, but let's just continue this way. This is just equal to square root of 2a squared plus 2c1 over, and that's y squared, so we can just leave that as y, because remember, y squared under a square root cancel out, it's just y. Okay, it's like this. So now I guess we can separate this. This is separable. So we can take the y over here, and we can take the x over here. As in, we can multiply both sides by dx. And when that does happen, dx into dy on dx is equal to square root of 2a squared plus 2c1 dx. Plus minus, of course. And this y will be here. I'll just take this symbol off. So it's equal to y into, because this y, we're sending it over here, cancels out. So it's y dy is equal to plus minus square root of 2a squared plus 2a. Now, can we simplify this anymore? 2c1. Let's take the 2 out, so it's a squared plus c1. And what's square root of 2? Well, I just realized that square root of 2 isn't happy for anybody. A squared plus c1. Nice. And of course, this is with respect to dx. And now when we integrate this, both of them, what we realize is this y, this is simple enough. This is just y squared on 2 plus c1. I don't think we want to be writing the c1 here, but it doesn't really matter. Because it's a constant, it's just going to delete anyway when you take it to the outside of the constant, and that will just become a constant. Now, integrate that. That looks hectic. Surely does. Let's just try use a u sub. Let u equals a squared plus c1 2a. Let's c1, that just goes away. Okay, nice, good enough. 2a 2. Oh, but there's no a. I guess we can multiply and divide by a. If that's how it works, let's look at the use of the answers took. The answers took a squared plus 2c1 y squared. Phew. Apparently, guys, we made a mistake. And that mistake oh, I see what they did. Okay. So what these guys are saying us to do is pretty simple. I'm just going to get rid of my 2. Quite hectic. I know this is taking a while, so if you're still watching it, I don't know why you're watching it at this point. I'm just uploading because I'm recording it and I can't delete the video, but watch, suit yourself. I don't care. Yeah, that 2, it gets multiplied here and here. Ah, I got the mistake. Remember, this is y to minus 2, there's a 2 here. So the 2 is still here, right? So when this gets multiplied by 2, that and that just goes away. Guys, see what happened? Look back to this step, right? I just added the 2 in here. But look back to this step. See this 2? We totally forgot to account for that 2 in the next line. That's where we went wrong. That's where everything went downhill. Because, well, my computer's just paid. But, yeah. you gotta put the 2 there, right? Because, and then when you pass over this 2, that just cancels out, because then it's like 2 into this, cancel, a squared. See, we never have a squared here, but then we do have for the 2 constant. We do multiply it for the constant, and now what you do is you find common denominator. So as in says y equals plus minus the square root of a squared plus 2cy squared over y squared. Okay, so we just multiply this by y squared on the bottom and y squared on the top, and then we can add it like this. And then in the next line we can take this y squared, because it's under a square root, that can just become y. A squared plus 2c1 y squared on y plus minus dy on dx. Now, this is simple. Now you know the drill. Multiply both sides. X. Multiply both sides by dx. What will that then happen? Well, that will just get cancelled out with the dx, and then they'll be left at the new dx here. And you can bring this y to the outside. Nice. Now, what you want to do is integrate and integrate this. We can let this equal to u. Right, so then du 2a plus, well, that's a 2. du is equal to 2a plus 2. Well, I guess that stays the same. Like if you, 2c, the power, that comes down. So 2, so that's 4 c1 y. Nice. That is du dx. Nice. But does it really help us? Because we have square root of u, and then dx, this is u, so then du is equal to this dx. So I guess we can send this entire thing over under the du for the dx. So it's a du over 2a plus 4cy. Nice. Do we all know how to get y in terms of u? No, we don't. And in this position, and what do you do next? Well, actually guys, I'm sorry, I forgot. As in, like, I don't know how to go forward at this. Let me check my laptop. Yeah, I'll get this over in like 5-6 minutes. Okay. History. Got to our nodes, then differential equation nodes. This is harder because the video is being recorded on my iPad, actually this time around. So all my notes are on my iPad, so that's why it's taking a little bit of time. Okay. So then du is equal to, well, we only care about the y, so it's just 4c1y. Yeah, why did I even take the 2a? That's just another constant. Nobody cares about the 2a. Then what happened is that they just didn't integrate it like that. They pulled it over here. Okay. Okay. So now guys, this is actually pretty simple and straightforward. It's really simple and straightforward. Okay? Got it. Okay, so see, du here, du is equal to, this is a, get rid of it, because we want du and dy, right? So du and dy is equal to 2, that brings down 4c1y. Okay, easy. That is dy, dy. That is good. Now look here. This is a complicated situation. We want dx on the other side. So y dy is equal to plus minus square root of a squared plus 2c1y squared dx. Yeah, times dx, it's here. And we can actually divide both sides by this term. So y dy over square root of a squared plus 2c1y is equal to plus minus dx. And then if we integrate both sides, well, you can't. Yeah, sure. Integrate both sides. What is this? Dx, that will just become x plus minus x plus c. And what is this? Well, this will be, well, yeah. We can let this be u. So you're integrating square root of u, as we will let that be, over, it's y dy here, y dy, for constant y dy. So I think it's just a matter of, for y dy cancels out, constant one doesn't really matter, yeah, easy, and then du. So to get the du, what they want is that 4c1. So 1 on du. Now it's du. What is this? That's just 1 over u to the half or u to the negative half. So 1/4 of u to the negative half, integrate, what's that? U to the negative half plus half. So u to the 3 on 2 on 2 on 3 into 1 on 4. What is this? That's just 2u to the 3 on 2 on 12. Okay, let me check if that was right. Let me check that was right. Let me check that was right. Let me check that was right. Okay. Okay, sure. I got it. So what they're saying us to do is, like roughly this line, right? Yeah, here, du. They just want us to move the 4 on the other side. So du want 4c. We can remove the c1. Actually, yeah, remove the c1. It's very irritating. Remove the c1 from the first place. This is alright, but I just want to make things faster. is equal to y dy. Why are we adding this? Well, not a big change, but this just makes it obvious. There's a y dy on the top, we can replace that with the du. So then when we get over to integrating, that will just become u to the negative half into this. Easy. And then what's u to the negative half? Well, that's just half, negative half plus 1, which is 3 on 2. 4c. And this obviously gets cancelled out, so that's 2. And it's 2 on the bottom. 2 into 3, that becomes 6. But why? What am I still doing wrong? They have square root of u. Oh, did they just flip it? Did they just flip it? Let me see. Did they just flip it? Like, we can continue, but I just want to get their exact answer. Yeah. Looks like they flipped it after. So this is just 1 on u to the half, right? Or like 1 on square root of u. That's what it is. So just so you all remember, this is just 1 on square root of u. So when we flip it, it will become square root of u into 4c on du. And we still haven't integrated. Nice. But then when we do integrate, we can take the 4c out. What's integration u? Well, that's 1/2 plus 1, which is now the 3 on 2. So then that's just u to the half plus 1, 3 on 2, 2 on 3. 4 into 2 is 8, 8 on 3. Well, that makes sense. That's u to the negative half. When you raise it by 1, that's just equal to u to the half on 2 into du on 4c. Easy. And there it gets cancelled out. That was the mistake I was doing. I was thinking it's 1/2, but it's a negative half. Negative half plus 1 is just positive a half. I was like, a half plus 1 is 3 on 2. That's where I went wrong. So this is just square root of u du. Well, and then yeah, square root of u over 2c, because we just integrated it, over 2c is equal to this, which is just x plus c. 2. And if we take it to the other side, square root of u is equal to x 2c1 x plus c2, or the plus minus, don't forget, plus minus. And then what's square root of u? It's this. So square root of a squared plus 2c1y squared is equal to 2c1 x plus c2. And I think that is the end of our answer. Yep. That is a that is indeed a solid piece of answer to a squared plus 2c1 y squared. And yeah, with that, thank you for watching this 30-minute long video. Hope you had fun.